Okay, this is our third video of the week. We are going to be graphing quadratics. It's going to go on page 8-6. And your content objective is we will graph quadratics using the vertex and axis of symmetry. We're given this quadratic function y equals x squared plus 2x plus 3. We need to identify what a, b, and c are. And a equals 1, b is 2, and c is 3. A is the number in front of x squared, 1. B is the number in front of the x term, and then c is the very last term, or our constant. So to find the axis of symmetry, we know that's going to equal x equals negative b over 2 times a. So in this case, that's going to be negative 2 divided by 2 times 1. So negative 2 divided by 2, that means that our axis of symmetry is going to be the vertical line that passes through negative 1. So now in order to find the vertex, we need to plug that negative 1 back in for x. So we're going to have negative 1 squared plus 2 times negative 1 plus 3. Well, negative 1 squared is 1. 2 times negative 1 is negative 2, so 1 minus 2, then plus 3. 1 minus 2 is going to be negative 1 plus 3 is 2. So that means that when x equals negative 1, y equals 2. So we know that we can sketch our graph. We know that the vertex is going to be at the point negative 1, comma 2. So negative 1, comma 2 is going to be right around there. We also know that our y-intercept is going to be positive 3. So that means it's going to look something like this. And then it's going to go up, and we're going to go on to the other side and do the same thing. So that's a rough sketch of this parabola. So now we need to graph x squared plus 4x minus 12 by completing the following. So the first thing is find and graph the axis of symmetry. Well, our axis of symmetry, that's just like what we did in the last example. X is going to be negative b divided by 2a. In this case, my a is 1, b is 4, and c is negative 12. So I'm going to have negative 4 divided by 2 times 1. Well, negative 4 divided by 2 is negative 2. So that means I can go and find negative 2 on my x-axis and draw my axis of symmetry down through that point. So that's my axis of symmetry, negative 2. I'll go ahead and label it AOS. In order to find the vertex, we know that we need to plug in our x value from the axis of symmetry back into the equation. So I'm going to have negative 2 squared plus 4 times negative 2, then minus 12. Well, negative 2 squared is 4, so I'm going to have 4 minus 8 minus 12. And so when we simplify all of that, we're going to end up with negative 16. So then we know that our vertex is going to be at the point negative 2, comma, negative 16. So let's go ahead and let's plot that. So we'll go over to negative 2, down to negative 16. We know that it's going to be on our axis of symmetry. So there's that point. And now we need to find and graph the y-intercept. Well, our y-intercept is already given to us. Our y-intercept is right there in the equation, so negative 12. So we can go ahead and plot negative 12. And there we go. And then, well, let me write that down. Y equals negative 12. find and graph 2 more points. What I would do is I would go ahead and I would plot the other, well, let's plug positive 1 in and see what we get. So if we plug positive 1 in, we're going to get x squared, or 1 squared, plus 4 times 1 minus 12. So 1 plus 4 is 5. 5 minus 12 is negative 7. So that means we're going to have 1 point at 1, negative 7. And then let's plug in 2. So if we have 2 squared plus 4 times 2 minus 12. 2 squared is 4. 4 times 2 is 8. 4 plus 8 is 12. 12 minus 12 is 0. So that means at 2, it's going to be at the point 2, 0. So we have 1, negative 7, and we have 2, 0. So now it says that we need to reflect those points and draw the graph. So if I reflect the points, I'm going to do the exact opposite. So what I see is that I have this point right here, which goes over 2, up 4. So I'm going to go over 2 and up 4 in the opposite direction. Over 2, up 4. There's its reflection across the axis of symmetry. And then I'm going to do the same thing with this point right here. So from negative 2, negative 16, I went up over 2, up 4, and then I went over 1, up 5. So I'm going to go over 1, up 5 to my next point. And then I'm going to go over 1, oops. I'm going to go, come on now, over 1 and up all the way to my x-axis. So I end up with this rough, horrible looking parabola. Now we have a real-world application. The height and feet of a rocket launched straight up in the air can be modeled by the function f of t equals negative 16t squared plus 96t, and the graph is shown. So question number 6, 7, and 8, they ask you questions about the graph, and what I would like for you to do is I want you to try to figure it out yourself. Just remember that our x-axis in this case represents time, and our y-axis represents height. So then you should be able to answer 6, 7, and 8. And this is what I will be checking for in class. Thank you very much.